Welcome to MyProjectBazaar.com. Let me discuss about the process channel estimation and equalization with adaptive modulation and coding over multipath faded channel for WiMAX. Let me discuss about the abstract of the project. OFDM, orthogonal frequency division multiplexing, is a form of signal modulation that divides a high data rate modulating stream, placing them onto many slowly modulated narrowband close-spaced subcarriers. Orthogonal frequency division multiplexing, or OFDM, is a modulation format that is being used for many of the latest wireless and telecommunication standards. The main causes of intersymbol interference are multipath propagation or nonlinear frequency in channels. Adaptive modulation systems invariably require some channel state information at the transmitter. Phase shift keying is a digital modulation scheme that conveys data by changing or modulating the phase of a reference signal, that is the carrier wave. Any digital modulation schemes uses a finite number of distinct signals to represent digital data. QAM, that is quadrature amplitude modulation, is a method of combining two amplitude modulated signals into a single channel, thereby doubling the effective bandwidth. Let me discuss about the flow diagram for our process. This these are the blocks for the OFDM transmitter, and these are the medium, that is channel medium, and these blocks are represents for the OFDM receiver. And initially OFDM transmitter, the input signal is generated randomly by using the convolution encoder can convert the input signal into binary stream. Adaptive modulation scheme is used for modulating the input signal, for which 16 QAM, 64 QAM and QPSK modulation schemes used. In block type pilots, all the subcarriers in some OFDM blocks, the whole spectrum, are reserved as pilot tones. In COM type pilot models, some predefined subcarriers in each block serves as pilots. The Fourier transform breaks the signal into different frequency bands by multiplying the signal with a series of sinusoidals. This essentially translates the signal from time domain to frequency domain. Next, in the adaptive modulation coding. In the adaptive modulation and coding scheme is a method which adapts its transmitting parameters according to channel state. Next, and is used in various modern wireless communication to maximize spectrum efficiency by minimizing the error rate. One of the strengths of AMC is the signal to noise ratio estimation and feedback channel for adaptation. AMC is sensitive to measurement error and delay. In order to select the appropriate modulation, the scheduler must be aware of the channel quality. Next, the OFDM receiver. The reversal operation of OFDM transmitter process are performed. Removal of guard and cyclic prefix is performed, and transform the resultant signal by Fourier transform. Transform the resultant signal and implemented demodulation scheme by using adaptive modulator, and Readme decoding process performed for the demodulated signal. Finally, the performance has been analyzed. The finally output signal is estimated over every channel and analyzes the performance, SNR, BER, and spectral efficiency and throughput. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, write the file and run for executing this process. Here this process will repeat for many number of channels. Here I declare number of channels as 100. Here the OFDM blocks are implemented. Both OFDM transmitter and OFDM receivers are performed. In the OFDM transmitter, input signals are transmitted via the channel. Then in the OFDM receiver, the incoming signals are received via the OFDM received block. And here adaptive modulation schemes are implemented. Here various adaptive modulation schemes are performed. And finally we analyze the performance graph of our OFDM systems. This process will take for more time for execution. After execution of the process, we analyze this is the input data signal. Here I display the input data signal graphical representation, and this is the encoded input data. Here we convolution encoder algorithm is used for encoding the input data, and this is the modulated signal. QA modulation are used. This is the 16 QA modulation constellation diagram. Next, this is the pilot initiation signal, and this is the noise. Here the noise AWG signal is added to our input signal, and this is the reversal operation, that is removal of pilot, and this is the demodulated signal. This is the demodulation of the constellation diagram of the demodulated signals, and this is the received data. This is the BR versus SNR graph, and this is the BR versus SNR graph between QPSK 16 QAM and 64 QAM. By varying the modulation algorithm, we analyze the BR performance. This is the BR performance with QPSK modulation alone, and this is the 16 QAM modulation alone, and this is the 64 QAM modulation, and this is the BR performance with for adaptive modulation scheme, that is adaptive modulation coding. Here by varying the different QPSK 16 km and 64 km by 1/2 channel and the 3/4 channel, and this is the throughput performance by varying the adaptive modulation schemes, and this is the capacity. Finally we estimate the capacity by varying the iteration number. This is the capacity of full channel state information including all pilots power, and here we analyze the channel estimation by varying the adaptive modulation scheme. Thank you.